Good day, everyone. I am Jean Kimberly S. Borja, together with my research partner, Winalin G. Manukay, and today we will be presenting our capstone research entitled The Climate Cost of Deforestation Examining Carbon Emissions, Forest Degradation, and Global Warming. This presentation will explore how deforestation drives climate change and the urgent need for mitigation strategies. Let's begin with a quick overview. Tropical deforestation alone contributes around 20% of global greenhouse gas emissions. This research explores the role of deforestation in the carbon cycle and looks at how logging, burning, and land use changes intensify climate change. The researchers will also examine potential strategies to address these issues, including policy solutions and deforestation efforts.
In 2023 alone, tropical forest degradation reached 7 million hectares. Forests cover 30% of the Earth's land and are critical carbon sinks. However, when these forests are logged or burned, they release huge amount of carbon dioxide into the atmosphere. This not only accelerates global warming but disrupts energy balance, water evaporation, and even cloud formation. The objectives of these capstones are fourfold: to investigate the link between deforestation, carbon emission, and climate change, to understand how degraded forests switch from carbon sinks to carbon sources, to examine the obstacles and accurate measuring deforestation impact on emissions, and lastly, to explore effective mitigation strategies in the policy and technical challenges involved.
Now let's proceed to our salient findings. The researchers' findings reveal that deforestation drastically affects the global climates in two key ways. First, by releasing stored carbon dioxide, it directly contributes to global warming. Second, it changes land surface reflectively and water movement, which can lead to regional climate changes, cooling in high latitude but warming in tropical zones. And now let's proceed to our table 1. This table summarizes the effect of deforestation based on region and mechanism. In tropical areas, tree removal increases atmospheric carbon dioxide and reduces rainfall. In contrast, high latitude deforestation may increase surface reflectivity, leading.
As seen here, one of the key takeaways is that many countries face economic disincentives to preserve forests. They often see more value in land for agriculture or development rather than as carbon sinks. Also, quantifying emissions from deforestation technically complex, especially when considering indirect effects. To conclude, deforestation is not just a local or national issue, it's a planetary one. It not only emits greenhouse gases but also alters our climate system in complex ways. Protecting forests must become a central part of our climate response, guided by science and implemented through strong policy and cooperation.
Here are several proposed solutions. Reduce deforestation rates through regulation and enforcement. Support afforestation, especially in tropical zones. Encourage responsible land use through incentives. Participate in international programs like REDD+, reducing emissions from deforestation and forest degradation. However, afforestation in colder climates offers limited benefit due to the unique feedback loops involved.
Despite knowing the effects, protecting forests is still very difficult. Political interest, illegal logging, poor enforcement, and lack of global cooperation are major barriers. Even with improved satellite monitoring, economic pressures often outweigh conservation efforts. Thank you for listening. Let us remember that every tree cut today has consequences that last for generations.